We're going to work on computing operations on functions. We're going to create sum of two functions, difference, product, quotient, and then we'll create something called the composition here in a moment. This is an introduction and it's part 1 of 2. The functions that you will see in this demonstration will be from this list. We're going to focus on the linear functions f and g first, and then later you'll see me refer to the polynomial h and then the two rational functions, capital F and capital G. Okay, so let's start with those simpler functions, the linear functions f and g. F of x is 4x minus 1. G of x is 5 minus x, excuse me. And we're going to use those functions above to create new functions. Let's start off example 1. Let's create the new function f plus g. Okay. By definition, the outputs of this new function f plus g of x are created by adding the outputs of the original functions f of x plus g of x. Alright, the output of f of x is the difference 4x minus 1, so we'll record that. We'll add to that the output of g, which is the difference 5 minus x. Now we'll try to simplify, if we can do that pretty quickly. Since we have the sum of these two differences, we can remove the parentheses and it doesn't change the sign of any of the terms. So we still have the first two terms, 4x minus 1, and we're adding to that the constant 5, and we're adding to that opposite x. And now we can combine like terms. The linear terms, 4x minus x for a total of 3x, and the constant terms, negative 1 plus 5. And so our new function happens to be linear as well. Its name is f plus g, and its output is 3 times x plus 4. The domain of the original two functions were all reals. And since this is a linear function here as well, the domain of our new function is all real numbers. Okay, let's continue by creating the difference function f minus g. Okay. Well, similarly, the outputs of this new function can be created from the outputs of the old functions, starting with output f, and then we'll subtract the output of g. Okay, if you recall, f was a linear function, 4x minus 1. G of x was a linear function, 5 minus x, and this time we're going to subtract. We can remove the parentheses from the first two terms, but when we try to remove the parentheses from the second two terms, we're going to have to change some signs. Okay, so simplifying, we're going to get 4x minus 1, but we're going to subtract 5, and we're going to subtract opposite x. Subtracting a negative can be written as addition, and that term becomes positive. And now we collect our linear terms for a total of 5x, and collect these constant terms for a total of negative 6. Our new function, the difference function f minus g, ends up being the linear function 5 minus 6 with the domain of all real numbers. Okay. You may want to pause a moment after I write down this next example and see if you can work it on your own, and then check it with my calculations. We're going to change the order of these functions, and I'd like you to create the new function g minus f. Pause now if you'd like to try it on your own. Okay, creating this difference function, we'll take function g, which was linear, and we'll subtract function f, which was 4x minus 1. We'll remove the parentheses carefully, so we'll have to subtract 4x, subtract negative 1, making it adding positive 1, And now we can collect like terms. And it looks like we have a constant 6, which we might list first, and then the linear term negative 5x. It just looks cleaner. But you could write your answer as negative 5x plus 6. Oops, I went off the page. Sorry about that, guys. Okay. Products and quotients work similarly. We just have to watch our domain of our new function when we create quotients. Let's stick with these first two functions, f and g. Let's create the product, fg, or f times g. Okay. The outputs of the product function will be the product of the outputs of the originals, f of x times g of x. And so we'll have the function f multiply times the function g. We'll write those functions in there. And now we're trying to multiply a binomial times a binomial. And we probably remember that process, or a memory aid for doing the multiplication is the acronym FOIL, FOIL, reminding us to distribute and get a product for the first two terms, the outer two terms, a product for the inner two terms, and a product for the last two terms. Let's do that. The first product, 4x times 5. The outside product, 4x times negative x. The inside product, negative 1 times 5. And then the last product, negative 1 times negative x, positive x. Okay. Are there any like terms? Looks like these linear terms, 20x plus x, will combine. Okay, so we're going to look for a term of 21x. But why don't we write the highest power term first, negative 4x squared. We have a total of 21x, and don't forget the constant negative 5. So there's our product function. It's just a polynomial in x, so its domain is all reals as well. Okay, let's take a look at this quotient, f divided by g of x. And we're going to continue to use those functions, 4x minus 1 and 5 minus x. Okay. So by definition, we have a ratio of f of x and g of x, where f of x is the line, 4x minus 1, and g of x is the other line, 5 minus x. And I think the reader can see that x cannot be 5, but we need to keep that in mind. The domain of f and g used to be, or are, all real numbers, but the domain of the quotient has to be restricted. We cannot plug in x equals 5. We cannot. Do you see why? If x were 5, we would be dividing by 0, and that would be, and that's not a real number. Okay, we're going to switch to composition, which is an important function in algebra and in pre-calculus. I'm going to slide in here a definition from the textbook we're using right now. Okay, let's see if I can get that into focus. And if you look in your textbook, you'll see some sort of definition for composition. The symbol for composition is this small circle, and that small circle is read f of g of x, the way it's here. It doesn't look like that's showing up very well, so I'm going to take that off the screen. Okay, let's continue to use those two functions from before, and then we'll move on to some other functions. Let's start with little f and little g again. And let's create the new function that's called f composed with g. The outputs of f of g of x are created. We let this last function g be the input of the function before it. this last function that's listed, g of x, ends up being the input of the function listed before it. Okay. Well, f of x takes 4 times the input and then subtracts 1. So we need to write down 4 times our input and then subtract 1. But our input is the function g of x. So we write down 4 times this difference minus 1. And then if it's pretty easy to simplify, we usually go ahead, distribute through the parentheses, collect like terms. Of course, we could also write this as negative 4x plus 19. The composition function ends up being this linear function, 19 minus 4x. We're going to find that composition is not commutative. And if you'd like to practice this next one and see what I mean by that, pause after you write down g composed with f of x. And I'll remind you that the definition says this second function, f of x, is the input of the first function g. And we need to record g of f of x and then plug in the functions listed above. Pause now if you'd like to try that on your own. Okay, I let some time go by. I forgot that you could pause that at home. Well, g was that linear function, 5 minus x. But our input is a function f of x. So we need to take 5 minus f of x, or 5 minus this green difference. Okay. When we simplify, when we try to remove these parentheses, we need to distribute the negative. So the second term ends up being negative 4x, and the third term ends up being positive 1. Collecting like terms, we see that this composition is 6 minus 4x. And if we compare f composed with g and g composed with f, we see we get two different functions. At least they have different y-intercepts. I see we're hitting about 13 minutes, so I'll stop here. You may want to go on to part 2 of this video where I continue with composition, but I will work with some different functions. Thank you.